Hey there, Internet. So I made some more progress. I did a whole bunch of refactoring on the code. I've actually moved over to the Brescian whatever the the line equation that I can't pronounce. So I've changed a whole bunch of stuff. It doesn't tremendously affect the demo that I'm about to do, but I think the underlying code base is easier to work with, and it's going to be running faster since it's got some optimizations in it. So the demo that I'm going to show is pretty basic. When you log into the app, you'll see this home screen. When you go to jog, you'll be presented with an option to change the pitch, and it's contextual. So the only thing that you can do in the startup mode is change the pitch. So I'm going to go ahead and change the pitch to 0.5 millimeter here. Then I want to set the mode to slave jog mode. And this is the mode where you're going to jog a certain distance that's going to be slaved to the spindle here. So I'm going to select my distance, which is going to be 1 millimeter, and I'm going to jog Z minus, which is going to be this way. So I hit jog. And if I want to cancel, I just hit cancel jog. So I didn't have that before. So you can cancel out of your jog. So now we're ready to jog. We turn the machine on. Okay, and there was a little bit of backlash in here, so I'm going to re-zero this. And you'll see we also get a notification that says we've gotten to our target. This shouldn't say error, so ignore that for a second. So if I hit jog again, I'll go another millimeter, and we're off about, I'd say about 1.5 hundredths of a millimeter. So we'll go one more. The DRO is not resetting every time. So one of the big changes that I had to make, or that I wanted to make, was because of the other implementation, I had to reset a bunch of the positions to 0 every time I was moving around. But in this setup, if I jog 3 millimeters, it should actually just jog 3 millimeters. So this should go to as close to 3 millimeters as it can get. The other thing I want to demonstrate is the fact that I can turn this by hand, and if you watch the DRO, we'll go ahead and be moving, but if I actually switch it the other direction, it'll act just like it's slave to a change gear until we hit the place that we originally started. So I've set a virtual stop at both sides of this distance. So if I continue to go the wrong direction, then we can see the tool went past the stop and everything stopped. So that's like a safety feature. It also, because you can set those stops, you can very easily bounce between the stops if you're working on a part. So that's the progress I've made. Now that I don't have to reset the positions, I'll be able to resync the position. So for instance, if this blue thing on the chuck is 0 and I'm in some other position, I can wait for this to swing around to get back to the original position, just like you would with a threading dial, and it'll dwell until it sees that position, and then it'll engage the feed. And that's what you need for the next step for me to do here, which is threading operations.